Section 4 of Chapter 8 is all about special kinds of parallelograms, rhombuses, rectangles, and squares. You're probably already familiar with rectangles and squares, but might not be so familiar with rhombuses. By the end of this section, you will be able to decipher between these three and know the different properties about them. So a parallelogram and a triangle are talking. Hey, I was thinking, I would ask Circle to dance. Common parallelogram, she's way out of your league. Here's Circle. You should take someone more like Rhombus. So again, this is kind of a dorky little joke, but rhombuses and parallelograms are very similar, whereas a circle doesn't even have angles. So these are the kind of things we're going to look into. We'll start with three different vocabulary terms that you need to be aware of. The first one is the rhombus, and a rhombus is a parallelogram, meaning all of its sides are parallel, but it has four congruent sides, so all of the sides are equal. A rectangle is also a parallelogram, but it has four right angles, so we classify the rectangle by its angles rather than its sides. However, one thing we do know about rectangles is that its opposite sides are congruent. So I can put my congruent markings like so. And then a square is a parallelogram with four congruent sides and four right angles. Hence, we can put our congruent marks here. All of these are side length A as indicated, and we have our 90-degree angles. To organize my information, I have a Venn diagram. So everything we're looking at in this section is a parallelogram, or another name for this is a quadrilateral, a four-sided figure. So all parallelograms are either rectangles, squares, or rhombuses. How to read this? Well, all squares, since it's the overlap of all of these different figures, all squares are rectangles. They are also rhombuses, and they are also parallelograms. Now, rectangles can be rhombuses if they're squares, and rhombuses can be squares if they're rectangles. So basically, just know how these are related. Basically, rhombuses, you need four congruent sides. Rectangles, you need opposite congruent sides and 90-degree angles. Squares, you need everything congruent, all sides and angles congruent. As a heads up, a bunch of corollaries and some theorems are going to come our way. You don't have to necessarily remember the names of these, just know how to use them. In all of these corollaries, the rhombus, rectangle, and square corollary, we have a biconditional statement, meaning if and only if. So here we have a quadrilateral as a rhombus, if and only if it has four congruent sides. That if and only if is the biconditional two-way arrow, so we can go both ways. We could first start with that a quadrilateral was a rhombus, and then we could state that all of its sides were congruent, or if we are given four congruent sides, then we could state that the quadrilateral was a rhombus. I like to pay attention to the symbolic representation. So here we have that ABCD, quadrilateral ABCD, is a rectangle if and only if all of its angles are congruent, meaning all of its angles are 90 degrees. And then the square corollary puts these two together. You have that something, a quadrilateral in this case, is a square if and only if it has all congruent sides and all congruent angles. So if it's a rhombus and a rectangle, in other words. A couple more numbered theorems coming our way. Just three in this case. And these all have to deal with classifying based on different properties again. So the first one starts with we're given a quadrilateral, and this quadrilateral is a rhombus if and only if its diagonals are perpendicular, so they hit at a 90-degree angle. Just for the heck of it, I will call this the perpendicular rhombus diagonals theorem. That way we know how to use it. The next theorem is that a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So here we have opposite angles, B and D, and its diagonal bisects it, meaning it splits the angle D into two equal angles, and the angle B into two equal or congruent angles. And I've got those marked. Similarly, the diagonal AC cuts the larger angles into two smaller congruent angles. I might as well call this one the rhombus angle bisector theorem. Again, you don't have to remember that, just know how to use it. Lastly, we have that a parallelogram is a rectangle if and only if its diagonals are congruent. So if you have congruent diagonals, you have that it is a rectangle. And this one's the one that is most used, in particular in construction, to tell if a window or door is square. Notice how I just said window is square when really this proves it's a rectangle. We use those terms kind of all over the place incorrectly. We use sometimes square to say perpendicular or right-angled. Speaking of construction, here's an example dealing with carpentry. So we're building a window frame, and whenever we're building a window, we want everything to be level and square. Now again, we say square, we really mean right-angled or perpendicular angles. And we have that the window is 44 inches tall, 33 inches wide. We go ahead and we measure the diagonals of this opening. So we measure one diagonal here and the second one here. And the diagonals are 54.8 inches and 55.3 inches. They are not equal. So what can we conclude about the shape of the opening? Well, the first thing we can conclude is that we do have a quadrilateral. And in fact, we have a parallelogram. I know that it's a parallelogram because the opposite sides are equal. However, this is not a rectangle. Because by the last theorem that we went over, in order for this to be a rectangle, the diagonals would have to be equal. And 55.3 does not equal 54.8. So the only thing we can conclude is that this is a parallelogram. These next two questions, we're going to be looking at relationships between rhombuses, parallelograms, quadrilaterals in general. And I do advise that you draw a sketch first to explain what's going on. So we first start with a rhombus QRST, and we want to prove that angle Q is congruent to angle S. So I first start by drawing a quadrilateral, and keep in mind, since it says rhombus QRST, we want to go in that same order, QRST, so that Q and S are not next to one another. You just want to follow the same order that it's written in. What we know about a rhombus is that all of the sides of a rhombus are congruent. We also know by definition that all rhombuses are parallelograms. And from a previous theorem, we do know that opposite angles of all parallelograms are congruent. So we can write these congruencies of angle pairings. From there, to prove that angle Q is congruent to angle S, well, it just follows from what we just showed using a parallelogram. Let's look at the formal write-up. Here's the formal write-up of what I just discussed. Feel free to write this down. You can pause it right here. I'm just going to keep moving on though. Again, we have a rhombus. We'll draw this rhombus, QRST, Q, R, S, and T. Rhombuses have all congruent sides. Decide whether the statement is always or sometimes true and draw a sketch. We need to show that angle Q is congruent to angle R. Well, just as before, all rhombuses are parallelograms. So we can say that all parallelograms have congruent opposite angles. So we can draw our angle congruencies. But angle Q is congruent to angle R. That's not always going to be true. Perhaps if this rhombus were a square, it would be true. So I would say if we drew our picture more like this, where it was a square, we had all congruent sides and 90-degree angles, well then yes, this would be true. But in this case, it's going to be sometimes true if the rhombus is also a square. Let's look at the formal write-up. So here's the formal solution, a nicely drawn picture. Feel free to copy this down if you'd like. This is the end of the video. You will be solving problems just like this in class in terms of recognizing whether something is a rhombus, a square, or a rectangle, and using its properties to prove congruencies or certain things about them. Please keep a running total of all of these theorems that we have learned. I know that there's a lot of them, so either in a notebook, if you're making some note cards, that would be a great way to keep yourself organized, but keep track because it is difficult with all of the different information that's being thrown your way.